Good evening, ladies and gentlemen. My name is Vardhan, and I'm super excited to be here on Edureka Live with you guys. In my previous session on DevOps, I explained how to Dockerize an Angular application using Git, Jenkins, and Docker. So today's session is the next in that same Docker series, and today I will show you how to use Docker Compose to containerize not just one Angular application, but to containerize an entire main stack application. So in simpler terms, the difference between my previous session and today's session is that in my previous session I created one Docker container and hosted an Angular application inside that. But this time around I will be using Docker Compose to create 3 different containers for hosting the main stack application. Angular will be hosted in one container, MongoDB will be hosted in another container, Node.js and Express will be hosted in the third container. And thus I will create my main stack application through Docker Compose. So guys, I can get started, but before that, let me tell you that if you get any doubt during this session, you can raise them by putting them in the comment box, and either my team or I will myself answer them for you. So sit back, relax, and enjoy Edureka Live for the next 30 minutes to learn how Docker Compose can be used to containerize multi-container applications. But before I get started, I want to first of all ask you people a couple of questions. The first is that, are you all aware of what Docker is? And the second question is, are you people aware what a main stack application is? Do pour in your answers there. Okay, I have a mixed response here. Some of you people know what they are and some of you do not. Well, don't worry guys, as you can see from the agenda, I will first introduce you to Docker, and then after that I'll talk about what is Docker Compose. Okay, so Docker Compose is the main topic of today's session. And when I'm done telling about that, I will then tell you how to create and how to containerize a main stack application. And since I'm talking about a main stack application, I will also give you an introduction as to what that is. And finally, I will give you a demonstration of how to containerize the 3 services which involve the main stack application. Alright, so enough talk. Let's get started. And the first topic for today is that of what is Docker. Docker is a containerization platform which packages your application and all its dependencies together in the form of containers so as to ensure that your application works seamlessly in any environment, be it development environment or testing environment or production environment. And as you can see from the image on your screen, we have 2 different containers here, right? So both these 2 containers, they both have their own set of application. It has its own dependencies and packages and libraries, and all these are tightly packed together. And these containers are powered by the underlying Docker engine, which is in turn hosted by your host machine. Okay, so these 2 applications are independent of each other, and they both are hosted on the Docker engine, which in turn is hosted on the host operating system. And this host operating system can be either Windows, or it can be Mac, or even Linux for that matter of fact. So now in the industry, what happens is Docker is hosted either on servers or inside a virtual machine on the server. Now in case if you have a big application, you will probably need multiple servers, or you might have to simply run multiple virtual machines inside the same server. And keeping cost cutting in mind, what we do nowadays is that we use virtual machines for running and deploying all these multiple applications inside that same server. So in that case, what happens is you'll have to of course start multiple virtual machines, right? And here each virtual machine will be running one application. And the problem that will rise when you do that is that of memory resources, correct? So since you're creating too many VMs, too much RAM will be consumed from your host machine. And because VMs need memory to be pre-allocated. But then the benefit with Docker is that so much RAM will not be consumed from the host machine. Only the application and its necessary dependencies will be packaged together, and it will be hosted on top of the host machine. And only when the container is active and running, only then the memory needed is allocated to it. Hence there is no wastage of memory resources as compared to virtual machines. And well, the other benefits with Docker are that since these containers are lightweight, they can be easily spun into action, and they can also be shared with other collaborators easily by uploading them to the Docker Hub. Well, that's about what is Docker, right? So the next topic is how to create containers, because containers are the actual deal, right? We always speak about containers because these containers are where your actual application is hosted. And first of all, how do you do that? We can do that by using Docker files. So these Docker files are used to create those containers. Well, these Docker files are used to create containers by building a Docker image, right? And this Docker image, along with these instructions to create the Docker container, they will also have all the project codes. So the same Docker image can be used to spin n number of containers, and each of these containers, they can have slight modifications based on the underlying image. So there won't be too much memory also consumed in that way, because you will have the base image, and on top of that, whatever changes you make between the different containers, they will just be those modifications that you make to that image. So you'll have multiple versions of that same Docker image, right? So the Docker container is just a running instance of a Docker image. And and basically the final image here, they can be uploaded to the Docker Hub and then shared with collaborators for testing or deployment. And then the active version or the active instance of that image Docker container is. So that's how simply Docker containers can be created and distributed, and we can have instances up and running. So if you look at the image on your screen here, you can see the different components there, right? So you have a Docker file, you have a Docker image, you have a Docker container, and you have a Docker Hub, right? So this is just to give you a graphical or a visual representation of what I just said. So these Docker containers are the actual deal, and these are the ultimate goal of yours. So we want to create Docker containers, and they are done by simply running a Docker image. Okay, so you create a Docker image which will contain all the needed project codes and all the needed libraries and binaries and all these things. And by just executing this Docker image, we can get a Docker container. But creating a Docker image is where the problem lies. Okay, well, it's more of a challenge, and you can do that by simply specifying all the necessary commands and all the necessary rules in the Docker file. So the Docker file, you can specify which image you want to pull from the Docker Hub, you can specify which version, what all you want to install inside the Docker image, and all these things. Okay, and when you build that Docker image, you can simply run it, and you'll get an active version of whatever you built, and it's totally custom. Okay, and once you do that, you don't need to upload the Docker container. You can simply upload the Docker image to the Docker Hub, and when you upload the Docker image to the Docker Hub, the hub will, from there, the other collaborators of yours can download that image, like your operation engineers and all these people. They can download it in your staging server or production server, and by simply executing this Docker image, they will get a running version of that image, which is nothing but a Docker container. And when they just execute that, and when they have a container running, your service is up and ready. It's hosted on that particular server or inside a virtual machine in that server. So that's how simple it is to create Docker containers, right? So that's about this slide. Now moving on to the next slide, and here let's see what is Docker Compose. And I want you to pay attention over here, because this is the most important part of today's session. And as the definition here says, Docker Compose is used to run multi-container applications, right? So based on what I just told you now, can you tell me what this definition means? Can you tell me what multi-container applications mean? Anybody from the audience? Okay, so guys, the thing is, when we say multi-container application, it simply means that when there are multiple services, you use multiple containers to host each of those services. Okay, now in case of small applications, it's fine. You might be able to run all the services that you need inside the same container, but there might be cases where you might want to use different different services and different machines. Now let's take the example of VMs or servers, right? So you cannot host all the services that your application needs in the same server. So if you want to use Nagios service, then that would be hosted in one VM. Okay, and supposing you have another web service that you want to host, then that can be hosted on a different server, or it will be hosted over there because of so many issues the server might face because of overhead. So that's the reason we create or we distribute our services over multiple servers. So similarly, in Docker also, we can distribute our services which are needed by the application over multiple containers, right? And Docker Compose is what is used to get all these different containers to be active, and it lets them interact with one another. And when it's ready and interacting with one another, we can have a complete application, and the entire framework can be ready. So an example of what I'm going to show you today is that of a mean stack application. So I'm pretty sure you all know what a mean stack application is, but for those of you who do not, don't worry. First of all, start from the right side of the image. Okay, I want to first explain what a mean stack is. So in mean, M stands for MongoDB, okay, and E stands for Express, A stands for Angular, and N stands for Node.js. Now these are four different technologies, and these are together used to create a web server, a web service, okay. And there are three different components involved over here. So for any web service, in fact, there are three different components, right? Primary components. One is the front-end client, where your customers or the end users would be interacting with on the web browser. So that's your front-end client. And then you will have a back-end server where your actual data processing happens, okay? And then you'll have a database which the back-end server will use to process the data. Yeah, so now that we have these three services, we have to simply host them in different containers. Right now, that's what I'm going to do here. As you can see from this image, I'll use one container to host one particular service. Now let's say I want to host my database, that is my MongoDB database, in one container. Then I would be hosting it in here, okay, and I would use container 2 to host my second service, that is my backend server. And similarly, I can use container number 3 to host my front-end client. So I'll have three different clients for these three different services, okay. And how do these three services which are running inside my container, how do they run? Like I explained in the previous slide, over here I said Docker files are used, right? So in the same way, I would use a Docker file to create a running instance of this container of that particular service, right? I would use a Docker file to create a running instance of what's written in the Docker file. So I would use a Docker file to create a running instance of my Docker image. And when I do that, I would get a container. So I would, to have three different services, I would create three different containers, and I would create three of these different containers using my three Docker files. Okay, I would write the rules over here to create these three containers. And the fun part comes here. Since there are three different containers, you have to get them to interact with one another, right? So the interaction between one another and hosting them together, that is done by this Docker Compose file. So this Docker Compose file is basically a YAML file, and here we specify rules like where the location of my Docker file is present, okay. So it would look for the location of where the Docker file number 1 is present, and based on the rules there, it would create a container. And similarly, based on what's written in my Docker file 2, it would create a different container. That's two different containers which are active. And then similarly, there's a Docker file number 3, which the rules which would be mentioned in the Docker Compose file, that would be used, and then you will have a running version of that. So that would be the third container, right? So Docker Compose file. So to just sum things up, a Docker Compose file, which is nothing but a YAML file, is used to specify where the Docker files are present, and based on that, three containers would be created. And along with specifying where the Docker files are present, we have to also mention what ports you want each container to interact with the other, right? So if I want my container 1 to interact with container number 2, to give you a better example, if I want my MongoDB container, which is my database, to interact with my backend server, which is nothing but my Node and Express, then I would have to specify certain ports, right, which would be open so that it could accept requests and provide response to. So those I have to specify also in the Docker Compose file, okay. These two things primarily. And in case any point of time, if I'm creating a database, then I would also use one container as a database. So at that point of time, I have to provide the links as to which container I'm using as my database, and I would use to retrieve data and store data and all these things. So these are the three important things that would be present in the Docker Compose file, okay. So the YAML file, which is the Docker Compose file, will have those three items which I just said, and by just executing that Docker Compose file, you have your service up and running. So that's how simple it is, and that's how good Docker Compose is, right? That's the big benefit. So I hope it's all clear to everyone, and I can just move on. And if you have any questions, please put them in the chat box, and I'll get back to you immediately. But in the meanwhile, there's one small slide, a small topic that I want to explain, and that is what is a mean stack application, because there are a number of you here who do not know what a mean stack application is, right? So in a minute, I'll just cover this. And a mean stack application is basically a full stack application, right, which involves a combination of these four tools. So it's nothing but a full stack application which involves the use of Angular as a front-end web service. It makes use of Node.js and Express as the backend server, and then it uses MongoDB as the database. So when we use these four technologies in combination to form a full stack application, we call it as a mean application, right? And this is exactly what I'm going to do. I'm going to create three different containers for these three services, and I will get them to interact with one another using Docker Compose. So that's it about my PPT, and I can get started with my I can get started with my demonstration now. So for my demonstration, I need to first of all open my virtual machine. All right. So let me just go here. This is my VM where I'm going to show you my demonstration. Please confirm if you people can see this screen of mine, the VM. Okay, great. So first of all, let me open up my terminal. And I'll also open up this folder where I have my project present. So mean stack app is where my project is present. So yeah. So as I was mentioning, we need a Docker Compose file, which is nothing but a YAML file to create Docker Compose, right? And that file is present right here inside this project directory of mine. And along with this, I also said that we need Docker files to create Docker containers. So what I'm going to do is I'm going to create two containers, one for the front-end client and for the back-end server, okay? And those Docker files are present inside these two folders. So this Angular app that you see, this is the front-end client of mine. So this folder contains all my project codes. It's present over here inside SRC. It has the package.json file, which specifies what versions or dependencies are needed for my project to run. And of course, it contains my Docker file also, right? Now, in my Docker Compose file, I've specified the path of where this Docker file is present, along with all the other details that are needed to create my front end. Okay, and similarly, I've also specified the path of where the Docker file inside my Express server is present. So this Docker file would help me build my server, right? My backend server, and the backend server, of course, it would use the app.js file. This is the entry point for the server, and then it would of course use the package.json file to download all the dependencies needed for my project, for my code, and then the modules and the routes and all these folders are there. So the second Docker file is present over here, and the thing that you might not find here is the third Docker file. Okay, so even though I have Docker files for my front-end client and my back-end server, I do not have one for my database. That's because I do not need one. I can simply download an existing image from Docker Hub, that is MongoDB's image, and I can use that as a database straight away. Okay, all I have to do is specify the port mapping between my MongoDB and my Express server and Node.js, and then it would all be up and running. So there's no problem there. I can get it done that way, and I've specified those rules in the Docker Compose file. So I think before I execute the Docker Compose file, let me explain what is there inside my Docker Compose file. Okay. So this is the YAML file. It's a very simple file. It's very easy to write the code here. And for your reference, I've also specified what each line does. Okay, after a hash. So I've commented out the meaning of each line after the line ends. Right. So if you're watching this video at a later point of time, then you can always understand what I've said by this. But getting back to my explanation, the first thing you have to write in your Compose file is the version of Docker Compose you're using, because certain versions of Docker Compose are not compatible with all the Docker engines. Okay, so based on your Docker engine, you have to use the appropriate Docker Compose version, and I've used version 3.0. Right, so you can choose one of yours, and you can start writing the other rules. And you got to simply define three different services for running your three different containers. Okay, this is a very simple step. So it's very straightforward. Like I said, we have three separate services, and we have them in three different containers, right? So the Angular is the service number 1 which I'm using. My front end client would be hosted inside this container. My Express is my backend server, and this container is going to contain the specified codes and all these things here. And this is going to be my third container, database, and this would be my actual database of where my data will get stored. Okay, So this will be my server, this is going to be my database, and this is going to be my client. Okay, and how do I start building it? Now that I've specified the name of the container, what I have to say is I have to specify the path of where the Docker file is present. And when I say build colon and the project and the directory where the Docker file is present, it would simply pick up the Docker file inside this container and execute it. Okay, so that's what I've specified here, because if you remember, Angular app is the name of the folder, and this is present inside the same folder. So I've just specified the path of the project, and similarly the Docker file for Express Server is present over here. So I've done the same over here. I've said build colon Express Server, so it would look for the Docker file inside this particular project directory. Okay, but however, for my database I have not specified build because I'm just downloading an image, right? There's no Docker file for my third one. So I've said image colon Mongo. So this would ask my or make my Docker to pull the latest Mongo image from Docker Hub. Okay, it would pull it, and I have my 3 containers ready, but I have to expose them, right? I have to do the port mapping. So that's the next steps I've done in all 3 containers. So here I've said port mapping would be 4200 colon 4200. Now what this means is whatever is hosted on the port number 4200 of my Docker container, that has to be mapped to one particular port number in my browser if I want to see the actual application being hosted, right? So I've said map this particular port number to 4200 of my local host machine. So this means that whatever is running inside my Docker container, that would also be visible, and I would get to interact with that application from this particular port number of mine. And similarly for my server also, which is hosted inside port number 3000 of my Docker container, that is mapped to port number 3000 of my local host machine. Okay, and again this is specified after giving ports in colon. Okay, and the same thing I've done for my database also. I've said ports colon, I've mapped it to port number 27017 of my Docker container to the port number 27017 of my local host machine. Okay, so that's all that's basically needed. And since I have a database, I have this one extra line here. I'm linking my backend server to my database, so that whenever my server gets a request from the client, it would go to the database and it would fetch the data from here, and it would return that back to the front-end client as a response. So for that purpose, the keyword is links, and you say colon, and then you specify the database, the container to where you want to link it to. Okay, so since my container name is database, I've simply specified database over here. Okay, and yeah, that's the that's all you need to specify in your Docker Compose file, and that's how simple it is. Okay, I hope the Compose file, the YAML file, is clear to everyone. So since everyone's clear with the YAML file, I'll explain both these Docker files which I've created. I created one inside my Angular app, and this is that Docker file. And if I open it, you can see that the codes here are very similar to the codes which I taught you in my previous session on DevOps, right? So for creating my Angular application, it's the same. I've first said, when I say from, it basically means I'm pulling a node image which is tagged with version number 6. Okay, I'm pulling that image and I'm creating a new directory inside that image. Okay, I'm creating a new directory /user/src/app, and since I want to create it from the parent directory, I've specified an option -p. Okay, and once I've created this directory, I'm moving my working directory to the newly created directory. Okay, so that if I specify working directory and specify the path, whatever commands are executed after this inside this Docker file, they would be executed from this particular location. And the reason I'm creating a new path inside my Docker container is because there are certain dependencies which need to be executed, like my package.json file and my project codes. All these details should be present inside my container, right? So for that reason, I'm specifying a path inside my container, and I'm copying the package.json from my local folder to my container path. Okay, and similarly, I'm just doing a run npm cache clean, which just removes the cache, and the important command here is run npm install. So when we just execute an npm install on our terminal, the same function will be performed as what's specified here. And what happens is, basically, it would initiate and it would look for whatever dependencies are specified in your package.json file. Now, as I said earlier, package.json file contains all the dependencies. It's mentioned all those dependencies which are needed for your project to run. Those are mentioned inside your package.json file. So when you do npm install, this would the node package manager would download and install all those dependencies which are mentioned in this file. Okay, and yeah, once it's installed, then that would be copied along with all the project codes. So there are a lot of other folders which are there inside, right? Like my tslint.json, my tsconfig.json, the src where my actual project is hosted. This is my project folder, and of course the end-to-end testing for that folder. All these folders would be copied into my Docker container. Okay, and the command for that is copy means copy everything in this folder to my container, to this path inside my container, and I'm simply saying expose port number 4200. This means that this application would be hosted on port number 4200. Okay, and I'm issuing an npm start command, which means that it would look for the folder called src app inside the container, and it would start executing the code. Okay, that's what npm start would do. This is going to actually start the initiating of your project, right? Npm start. Npm stands for node package manager, and if you recall, I've said expose port number 4200, right? I've specified the same port number in my compose file also. So whatever is hosted in that port number 4200, right, the Angular app, this will be mapped to my local host port number of 4200 over here. So that's how the logic works, and that's what I've specified inside my Angular client's Docker file. And similarly, if I go to my Express server, which is my backend server, and the rules for building that image are inside this Docker file. And first of all, it's pretty much the same. All the commands and all the lines are the same, except for the port number on which it's going to be hosted, right? So I'm going to expose port number 3000, indicating that my node and Express server will be hosted on port number 3000. Okay, and yeah, the remaining are the same. I'm downloading a node image as my base image, and I'm moving it, making a new directory, changing the working directory to that one, copying the package.json file, running npm install, and all these details would be the same. Okay, it's just my port number which is going to vary. So yeah, that's what's going to happen when I execute the compose file. It would first look for the Docker file inside this, that is this Docker file. It would execute all this and create a new container, and then it would go to the next service, and the next service is building the Express server Docker file. It would execute this one, build all these details here, and then finally it would download a Mongo image from the Docker Hub and do the port mapping, and yeah, expose it so that the server can interact with this particular service of mine. So that's simply the explanation to whatever is there in today's session. Okay, now let me quickly execute and host the main stack application by going to my terminal first and issuing the command. Okay, so currently I'm in this folder /home/edureka. So I'm gonna cd first to main stack app. Okay, let me clear the screen and let me do an ls here. So this is the same folder where I showed you. The Angular app is here, the Express server is here, and then the compose file is here. Now I have to simply execute the Docker compose file, and the rest would be taken care of by my Docker compose itself. Okay, and the command to execute your Docker compose file is docker -compose --up. Alright, so when you hit enter, basically everything is getting built. Okay, your Angular app is getting built, your database is getting built, and your Express server is also getting built. So let's just wait for a minute here until my application is up and running, because it's a pretty heavy application, right? It takes a couple of minutes to get the thing up and running. So my ng server is happening, and it's hosted at this local host port number. My server is connected to the database at this port number. Very good. And guys, in the meanwhile, till it gets compiled, you can put in your questions if you have any. You can put them in the chat box, and Either me or my team will get back to you as soon as possible. Okay, so on port number 4200 of my local host, my Angler client would be running. That's great. Is listening on this port number. Alright, it says webpack is compiled successfully. Great. So now I can verify if my service is if my web server is up and running by opening the port numbers through my web browser. So I can go either localhost colon port numbers, or I can simply say 0.0.0.0 colon port numbers, right? So okay, so I'm going to do a localhost colon 4200. So this is where my Angler client is hosted on this port number. So this is the client, and my application is all about creating a contact list. So I've created these three fields for first name, last name, phone number. When you add the details, when you hit the when you add your details here and click on add, the data would go into my database. Okay, so let me first of all show you my server, and I'm going to do a localhost colon 3000, and yes, it says foobar, so this means that my server is also up and running, it's hosted. So localhost for my MongoDB, and that's on port number 27017. When I hit enter, it says looks like you're trying to access MongoDB over HTTP on the native driver port. Great, so this is the message you're supposed to receive. Perfect. So like I said, this is my client, and when I add the details here and hit add, then those details would go into my server. Okay, it would actually go into my database, but I cannot view the details that are there in my database. So I can I'll be using my server to view those details. Okay, so let me first of all add my name here. Okay, I'm gonna say Abhinav. I'm gonna add my last name here, then I'm gonna add a phone number here, right? So when I say add, you can see that the same details have gone into my database. Okay, so the UI that you see here, this is of the database, and we can also verify that by going to our server. Okay, now my code is such that I can view what is there in my database from a particular API call. Okay, and the API call I'm routing it to is API/contacts. Okay, so when I hit enter, you can see that the same details are present over here. Correct? These are the details that I added: first name, last name, and phone number. And this is the internal ID that was created when I added these details. Now similarly, let me add more details now. Okay, let me say ASD, and I'm gonna say QWE and phone number 123. Now just for you to understand things, so when I hit add, that has gone into my database, and I can view that what is there from this particular API call, right? So this API/contacts, this API call is going to be made to my server. And let me refresh this. Yes, as you can see, those details are present right here with a new ID. So that's how you can create a web server and host it with the help of Docker, right? So I have one database, I have one server which interacts with the database, and I have one client which can be used to either add details to your database or get details from your database. So I can even let me show you one more thing. So there's a delete option, right? So if I delete this, the record is eliminated. So if I do a refresh, that's gone, right? So it's eliminated from here also. So that's how the that's how my web server was built, and that was the purpose of my MeanStack application. And yes, you can create one of yours in the same way, and well, in fact, it's it can be done otherwise also, but the point of this whole session was how to do it using Docker, because Docker is one of the best ways, the easiest ways to create this, and you saw right how simple it was for me to create this web service and host it on my system. So that's the brilliant thing about Docker. And yeah, if you guys have any doubt, do drop in. But in the meanwhile, for those of you who don't know how a main stack application works, and for those of you who do not know how these services are interacting with one another, I'm going to spend a few minutes, just a few minutes, to explain this particular aspect, okay, of how my main stack application is. But yeah, it's pretty much the end of my Docker Compose demonstration. Okay, so going to my main stack app, I'll first explain my front-end client. Okay, now this is my Angular app, and this is the project directory. And if you see, if you remember from the Docker file, when it does an npm start, right, it would look for my project codes, and it would look for my project codes inside this directory by default, /src/app. Okay, and it would basically, we have the TypeScript formats here, the TypeScript files, right, .ts, app.component.ts, app.module.ts. So these are the TypeScript files in which I've written the Angular code, and these would be converted indirectly to JavaScript. Okay, and that would be taken care of by Angular. In case you are using Angular JS, which is the first version of Angular, then you can just write JavaScript files. But since I'm writing it in TypeScript, it would be transpiled automatically with two JavaScript files, and those would be called one after the other, and they would be executed. Okay, so yep, that's the thing. That's the most important aspect that you need to know about my front-end client. So whatever details are there, those would first go to the server, and the server would do the storage. And let me just go to the Express server folder here and explain on a high level what's happening. So when we do an npm start from inside this folder, then it would look for my app.js file, right? So this app.js file is basically, it's going to contain all the function calls, right? All the APIs that I have. If I want to add data, if I want to retrieve a particular record, or if I want to delete a particular record, all those API services are defined inside this file of mine. Okay, and this routes folder, this contains another folder called route.js. Okay, now this route.js file, this is where all the rules as to what needs to happen when a particular function call is made, right? When an API call is made, what happens, whether data is added to it or whether data is deleted from my database, all these details would be present inside this routes folder. Okay, so it's the function call would be routed to my routes, and then whatever action is there, that would be executed on my database. So on a high level, that's how it works. And I cannot explain the entire thing in detail because it's a little elongated video, and it's not something that you people can understand in one session. And that is the reason there's another video which I want you to see if you want to understand how a front end, how a main stack application is deployed. So we at Edureka have made this video tutorial called Main Stack Application Tutorial, and here one of my colleagues has recorded a brilliant video which explains exactly how a main stack application works, right? So it's based on the same structure. It involves the 4 technologies of AngularJS, Express, Node, and Express.js. Okay, so you can verify this video completely if you want to understand how the web hosting is done. But since my aim for today's session was to show you how to do it using Docker Compose, I've done that successfully, and I think I can conclude my session with that particular note. So let me just quickly go back to my slides and finish it up by showing this, by concluding this session. Okay, so we spoke about what is Docker. I explained what is Docker Compose. I then explained what is a main stack application, and then I finally gave you a demonstration, right? So check all the 4 points which I needed, they are completed. And yes, that is the end of my session for today, guys. And there's another thing which I want you people to remember. If you want to be notified of future live sessions, then I would request you to first of all like our videos and click on the bell icon which is next to the subscribe option. Okay, so you'll be notified of any live sessions in the future if you click on the bell icon. And of course, we want you to like our videos, comment, and all. Like, comment, and share our videos so that we also are encouraged to do more, right? So we have a DevOps playlist here explaining what is DevOps, giving you an explanation as to what are the different tools that are there, and giving a detailed explanation of how each tool works. So you can check out our Edreka playlist here, and yes, you can learn a lot from here. And of course, finally, I just want to go through the landing page of ours. So this is our course landing page, and if you want to learn DevOps from Edreka, you can go to this website, and yeah, you can see the batch details, what is the price, and of course the curriculum, and what all you will get to learn in our course. So you have all these details over here. And in fact, not just for DevOps, we also have one specifically for Docker. So we have a standalone course, and similarly you can see all the other details on this page, right? So I would request you to come here and contact our sales team from the contact number that's visible over here. So that's it, guys. That's it from my side. I thoroughly enjoyed this session, and I hope you all have learned something new today. And we will come up with more live sessions. Do subscribe to our channel, like, comment, and share our videos, and it will be a pleasure to have you on board with us. So thanks again, and happy learning.